Good morning,
Right
everybody.
on.
How we doing?
Everyone knows me as Francis. This is Steve.
Hi, Steve.
What local are you out of?
915, Tampa, Florida.
120 with 100% humidity.
Absolutely, all the time, like the
San
bottom of the
Jose,
ocean.
dry heat. 110, nothing. Who here wants to learn about controls?
I do.
Oh, you all suck.
Was that all of them?
I was at the casino down in Detroit, throwing 8s, throwing 10s. I was getting it going down there. I think I can make a new career over there, but since I love controls, let's talk about it today, Steve.
Okay, we can do that.
All right. Basic controls. Everyone has to walk before they can run. Every baby has to crawl before it can walk. What we're going to talk about is a very basic level of control. So every time you open up your refrigerator, whether you know it or not, there are controls in that refrigerator. If you turn on your car, that is controls. You turn on that light switch over there, those are controls. You flush the toilet, that is a mechanical control to maintain a level inside of the tank, which allows everything to be flushed out. Huh? Steve?
We're also going to talk about automatic controls. And these are things that take care of it for you. There's no human interface involved. We're going to talk about controls that take care of themselves. Level switches, things of that nature.
Why do we need controls? Why? Why do we need to know about them? We let the controls guys do them, right? We got these guys over here. They know their controls. Why do I need to know controls?
Electrons going through it, it's mine.
Because controls are everything. Everything you do in your life is about controls. If you want to be able to troubleshoot a problem, you have to be able to know how it works. Well, first we're going to learn about manual control. What do I mean by manual control, Steve?
Manual controls typically, when there's a human interface involved. Someone actually has to push a button, flip a switch, turn a knob. It's manual control.
Automatic control. What do I mean by automatic? It means my life is easier because I can have something do it automatically for me. When I open up that refrigerator, I want the light to turn off when I close it because I don't want to be like Mr. Power Factor over there wondering the vector angle of that goddamn LED inside of there. When I sleep at night, I want to be like, whew. I don't need to know about vector angle. That little micro switch that closes when that refrigerator door closes, it turns off. That's all I need to know. Ladder logic. Oh, whew, whew. Oh, God, we went there, huh? Ladder logic. Well, to be able to draw the logic out, we have to do it in such a way that I can hand it off to another journeyman and have him complete the project. If I'm the foreman and I hand someone a piece of paper, they should be able to read it, whether it's a one-line diagram, a blueprint, or a ladder logic diagram, because typically if you open up your furnace, the first thing that you see in there is ladder logic. And if you don't know how to read it, are you going to call me out there for $200 an hour? Hell no. You can be able to replace that little fuse by yourself. Maybe it's something as simple as the terminal block isn't making the correct connection. So let's learn how to read ladder logic, Steve.
Okay, if you guys don't know how to read ladder logic, don't worry. By the end of the course, once we get done, you guys will be able to read ladder logic. Fantastic, we'll make sure of that.
So let's pass out some control problems. Don't get scared.
Take half, I'll take half.
We'll get through it together.
I'm going to pass those around. We have enough for groups, 1 per 2 people.
So work in a team, typically in my JATC, nobody knows anything about this. This is something in new territory. I create a little sample problem, something that you have to work through, pretend that this is your customer, and he requires that this operation has to be accomplished. You're on the job, you're handed this bid, maybe you're going to make $100,000 doing this little piece of control work. Huh? 100,000 is nothing. That's just me waking out of bed. You know, I do this for a living, bro. All right, so one of the other things that we're going to talk about are PLCs. Once you get past basic electromechanical controls, which we're going to demonstrate in the lab, we're going to have you wire them up. We're going to do relays, timers, switches, push buttons. We're going to push so many buttons, you're going to get sick of them. Then we're going to go to PLCs, and that's where the real magic happens. We're going to talk about input, output, examinative open, examinative close. We're going to go through the full gamut of controls. But first, we got to walk before we can run. So manual control, snap switch, Steve.
Okay, so through the course, we're going to talk about some of our basic types of switches and different things that are used in manual and automatic control. Unfortunately, at this time, we don't have anything to pass around for you guys to play with while you're sitting here, but later on, when we get out into the lab, Francis will have you pushing buttons until you don't care.
So what do I mean by a snap switch? So first, we have to learn the terminology. Just as you were talking about blocks and bows and eye splices, that's his terminology, and I think that's awesome we learned about that. But here we're going to learn about controls, and a snap switch is nothing more than that switch that you see there on the right. You turn it on and off. That is called two-wire control. Start-stop controller. This is what we refer to as three-wire control, meaning that you'll physically need 3 wires in that pipe to be able to operate it from a remote station. Start-stop is simple as 2 push buttons, one labeled stop, one labeled start. Hand-off auto. This is something that we're also going to do in the lab as well. It's a 3-position selector switch. 3-position, 2-position selector switches. These are terms and verbiages that you're going to learn by the end of this lesson.
I like the auto part of that one.
Auto is awesome.
Yeah. Set it and forget it.
So the reason why we have hand in that particular switch is if the automatic portion does not do what we require it to do, like the level of that tank goes over the edge, we need to turn it to hand to manually control it, bring it back into our control. Disconnect switch. Steve, what is a disconnect switch?
Well, disconnect switch just simply disconnects the power.
There we go. And that's something that I have in the JTC. You're going to be turning that disconnect switch on and off, which could be fused or it could be in a circuit breaker. We're going to go over the NEC code and the required safety requirements before you even attempt to open up that cabinet. As you talked about before, safety is one of the most important parts of our trade. And when you're doing controls, just because it might be 24 volts doesn't mean that we don't have 120, 480 coming into the same cabinet. And even though you turn off that disconnect switch, you still could have 120 in that cabinet. You just don't know where it's coming from. One of the problems with that is that there has been electricians that thought that when they turned off the disconnect that everything was dead. Never assume that it's dead. Foot switch. Where do we use a foot switch, Steve?
Well, I can tell you that we used a lot of foot switches at Busch Gardens, Tampa. I used to do roller coasters out there, and I'd get a lot of calls out because someone lifted their foot off a foot switch before the train was out of the station. So a foot switch is simply a switch controlled by your foot.
Awesome, Steve.
Thank you.
Here you can see some examples of a push button, a foot switch, and a handoff auto. A push button, as you can see up there in the upper right-hand corner, the operator has to physically push it. There are some that are maintained, and there's some that are momentary. What do I mean by momentary? I mean that when you push it, it springs right back to where it came from. So if you have something that's normally open or normally closed, it's going to revert back to what we call shelf state. If you see that toggle switch right there, that's something that you might see on a control cabinet. I've had to go into plants before and try and troubleshoot something and realize that the toggle switch was in the off position. And this guy is doing all these different jumpers, and I had to turn it on and say, hey, let's turn on the power before we start troubleshooting the real problem. Foot switch down there on the right, typically in my local, since we do a little bit of pulling, this is a safety device. If you do not have a foot switch connected up to your tugger, you'll be like that guy with that thing whacking you, and that whole the whole tugger will rip up, and you'll have no way of unplugging it. So foot switches is another safety device which should be part of the tugger. Down on the bottom left-hand corner, that's a handoff auto. There's 3 positions that you can select it to. The legend plate dictates to what that operates. Here's an expanded view of a push-button switch.
When we get into the lab later, we're going to be taking some of these apart. You guys will be actually setting all this out in front of you. You'll have to put them back together and finally use them in the lab.
So in my JTC, one of the things that I typically do is I hand out push buttons to the apprentices and have them take them apart, because the first thing you realize about a push button switch, like this one back here, that the operator and the contact block are 2 separate devices, and you can buy them for whatever application you need to use. So if you need emergency push button, so when the shit hits the fan, you can just hit it and turn everything off, then you need a big red mushroom push button. If you need just a regular start-stop, it'll be typically recessed. There's other ones that are caged, other ones that have LED lights inside of them, and that will light up when you turn on the circuit. Automatic control switches, float switch. Where would you use a float switch, Steve?
Pump station, lift station, anything like that would use float switches. And this is obviously tied into the automatic control scheme. So the float switch, very simple. It can be normally open or normally closed. It's in one state when it's down. It's in another state when it's up.
You know, funny you mentioned float switches, Steve. The handout that we handed out to everyone has 2 of them. That's really amazing, isn't it, Steve?
That is quite the coincidence.
I would have never thought that the handout that we gave to everyone would include 2 float switches.
I don't know how that happened.
Limit switch. Where would I typically see a limit switch?
Door. Conveyor line.
Roll-up doors, conveyors.
Refrigerator. Every time you open up your vehicle, as soon as you open up that door, the lights turn on. And when you close the door, the lights turn off. And how many limit switches did you have to deal with at the roller coaster?
Too many to count. I mean that, too many to count.
Exactly. They're everywhere. So this is the verbiage that we're going to teach you. So when you look at a switch, you don't just call it, oh, I want a switch. You want either a float switch, a limit switch, a flow switch. Mention flow switch. I bet these instructors don't realize that in every building that they go into, there are all of these things inside of their building. Where would you typically see a flow switch? Fire alarm, fire life safety. We have to know if the water is flowing, trouble.
I think they'll know that before the flow switch says that there's a trouble.
Level, capacitive. Where would you typically see a capacitive switch?
Well, capacitive switches, magnetic switches, all of those can be used for gate control. You can use them pretty much anywhere in a process, right?
Anywhere you need to monitor something that passes over it, like a roller coaster passes over capacitive or optical switches. Any assembly line, you're going to need to be able to monitor the product as it passes by. You're going to need to get a count. Sometimes I get calls out because the labeling machine is spitting out labels even though there's no product there. Well, that comes down to a couple different things. One of them is the input of the capacitive or the optical sensor, but the other is the PLC programming. What's that, Steve?
Well, those would be magnetic and capacitive switches.
Oh, funny. It's like it's in sequential order. These are some examples of optical, magnet, and capacitive switches. These are something that when you take that roller coaster ride, if you look down, you'll notice them all over the place. If you're in an assembly line or any kind of industrial or manufacturing plant, these are mandatory. And we're going to get into why they use them rather than a limit switch. This is something more advanced. Later on, we're going to talk about that. Float switches. So in your handout, there are 2 float switches. This one that you see behind me has 4 float switches. Notice that they're hanging down and they have a little black ring around them. That's the weight to hold the cable down. You don't want the float switch floating all the way back up. Some of them are tied like that one there, tethered to the location. The float switch is as simple as it will turn up or turn down. So its shelf state is how you wire it up. you'll typically have normally closed or normally open depending on the operation of what you want to achieve. Sometimes, like with a sump pump, you want to drain all the water out. Other times you want to maintain a level.
Does anyone have any questions on how float switches work before we move forward? They'll be part of your project later on.
No, Steve.
Thank you.
Thank you, Steve. This is a project that I worked on myself personally at the water treatment plant in San Jose. They're expanding all of the water treatment process. More people are moving in. We have way more people coming in every day. And one of the things that you have to do is be able to control the level inside of a tank.
Those two pictures didn't end up right.
That's too bad, because the one on the right, it has all the components that you're going to see inside of the lab. One of them is a control transformer.
Can anyone tell us how a control transformer works? Anybody?
Induction from the primary coil to the secondary coil.
Okay. And control transformers typically going to take what voltage and convert it to what's most common?
480,
480, 120, or
120.
24 volts?
So typically what you're going to do with a control transformer is you're going to have your three-phase coming in, and the biggest problem with apprentices, I notice that they're so used to wiring up three-phase transformers that they forget there's such a thing as a single-phase transformer, and it's going to take single phase and transform it into a lower voltage of single phase. So when I typically ask them when we go line to line, what is the voltage I'm going to get across line to line? I hear a lot of them say 277 or 120. I'm like, maybe you should revisit the books and think about that, because when you go phase to phase is different to phase to ground. So this is something that I typically ask the apprentices to get that out of the way. Then we go into series and parallel connections, bringing you back to second year.
Before we move too far away from control transformers, I want everyone to keep in mind that just because you throw the disconnect switch, that does not mean the control system is dead. Sometimes your controls are fed from a different source. You should always check that before you just assume.
So typically one of my tests in the lab I have before they go in to wire something up, I have them come in front of a control board and they open it up and then they start wiring it. I say, whoa, what are you doing? You trust me? You trust Fantastic to turn off that switch?
No one should trust
No one should
Francois.
trust me. No one should trust Steve. No one should trust anyone. Trust but verify. That's your number one rule of safety. Before you put anything, put your hands, your face, anything inside of that control, even before you open it up, make sure that you know what you're getting into, because before you get into something, have a little bit of knowledge, because some people have opened up the door and it's exploded on them. So be careful is my number one rule. Pilot lights, motor contactor, and overloads. These are something that will scare people, like the instructors up there. They're looking at this like, whoa, what is this? What the hell is this? Pilot lights, they're used to indicate a part of the process. They'll turn on and off. Motor contactor, we're trying to control those three phases with a single phase 120 or 24 volt source. We have overloads. What are the overloads used for, Steve?
Well, if the system does have a problem, or the motor has a short in it, or there's an issue with the wire, the motor overloads, the overload should trip. The motor overloads are typically going to open if you get some kind of lock rotor issue or the motor starts to draw too much current.
So this goes back to what my power quality man likes to refer to as saving money. I love saving money. So if that $10,000 motor is overloaded or the bearings go bad or is starting to single phase, we want to protect that motor, number one, and we want to protect our investment, our money. So the overloads accomplish that, and once we get beyond 1 horsepower, they're mandated by the NEC, and they're sized according to the nameplate, which is something we're going to get into later. Oh, Steve, what the hell is this?
Symbols. Stuff they need to know.
I thought we weren't going to go to Egypt.
But I'm the tech guy. I do tech stuff.
Don't let this scare you. It's like hieroglyphics right now. To the instructors up there, they're looking at like this, oh my God. But when we start looking at this, We're going to be able to draw it out and understand what every symbol means, because we need to use symbols to represent what we physically see in the field. We can't physically draw out everything on a piece of paper and wire it line for line. It would become way too difficult to understand.
But what if what they have on their print isn't on one of these standards?
It just so happens that there's a legend. The same when you're reading a blueprint, all of these symbols are used on the print so that you can understand what you're looking at.
So there's like a symbol library
Yes.
on the print itself.
It's funny. You should mention that, Steve. What are we looking at here? This is ladder logic. We have two pumps. We have a control transformer. We have a two-position selector switch. We have multiple floats. We have a buzzer. We have a control relay. Right now, this might look like nothing to you, but by the end of this, you're going to understand it. We have three-phase at the very top connected to two motors. We have a control transformer that steps down the voltage, and then we have all of our controls down below.
Can anyone tell me what's not currently involved in this setup? Well, there is a switch. There's no manual override on this one. So unless this is automatic control or nothing.
So manual override, handoff auto, start stop. You don't see any of that there right now, but later on you're going to understand why some circuits have this and why other circuits don't. Oh, Steve.
I thought we were going to get deep into this.
This is just an introductory course. I don't want you pulling your hair out. You see this head of hair? You think I pull this head of hair out worrying about this stuff? We take baby steps, one line at a time, one wire at a time until you understand it. You start here, you're going to be like this guy up there. Steve, there's multiple ways to control the level inside of a tank.
Ooh. Control level, now that's different. But measuring the level, that we can do. With these devices, we've got microwave level gauges, radar, differential pressure. All of these things we can use to look at level.
Which is instrumentation. Instrumentation, that's a whole other set language that you have to learn. When you're talking about differential pressure, mag flow meters, bubblers, position sensors, all of this stuff, that's a completely separate field, but all ties into controls. This right here, this is a simple line diagram of an HVAC system. This is something that in my local and every one of your locals, including this building right here, this is a maintained space, meaning that there's a thermostat that monitors the temperature. If we cannot do that, then everyone will be crying about how hot it is, like over at Mason Hall. We don't want that. So this is something that you have to be able to understand the verbiage of HVAC, which includes all the requisite controls. PLCs and marshalling cabinets.
Well, what is a PLC?
Yeah, what is a PLC?
Can anybody tell us what a PLC is? What's it stand for?
Programmable logic
A
controller.
programmable logic controller. What do we use those for?
Run factories.
I'm getting a lot of different answers. That's
There's a
good.
lot of different answers. That means they can be used for a lot of different things, right? So what happens is inputs go in, magic happens, and stuff comes out the other side.
I call it PFM, but that's a little too much for you to understand. Anyway, PLCs, this is something that you're going to learn later on. There's inputs and outputs. This is something that you see there on the right. There will be a bunch of cards. There will be input cards and output cards. As a wireman, typically your job is to be able to terminate the remote wires on the terminal blocks. When they talk about marshalling cabinets, they're talking about nothing more than terminal blocks. So a lot of this verbiage and this slang that you talk about, like when you're a lineman or when you're rigging stuff, it's the same slang that we use when we're doing controls. And once you learn it, you understand it, it becomes so much easier to understand.
Now, why would we need a marshalling cabinet instead of just taking everything from the field directly to the PLC or the DCS control center? Can anyone tell me why we would need a marshalling cabinet?
Yeah, Steve, tell me.
Well, marshalling cabinet makes it simple to not only jump into the loops, but it gives you a center point. So if you have a changeover in the future, you've already got everything in the marshalling cabinet. It makes the changeover very simple.
Plus, my wrist right here, this is a scrawny little wrist, but I put this guy in the marshalling cabinet, and he starts wrenching down on those PLCs, and one of those screw heads pops off or strips. Can we buy another PLC input card, or can we get another terminal block? Huh?
Well, we could buy another input card, but you might not be on the job when it gets in.
They might not like that. So typically, everything is terminated to terminal blocks. Huh? This is a project that I worked on. As you can see, all of those blue wires, they have a specific purpose. So what I had to go through was I had 3 levels of prints that I had to look and verify that all of my terminations were going to the correct terminal block, because the worst thing that can happen, number one, is you terminate to the wrong terminal block. It makes troubleshooting incredibly difficult. What's this, Steve?
Well, it looks like PLC input-output.
We have a start, we have a stop, we have overload, we have a little float down there, and we have an output going to some solenoids and a motor starter. So it can be that simple. Once you understand PLCs are nothing more than input and output, the same with which this HVAC system works, which is another form of control. We have inputs and we have outputs, whether they be analog or discrete, meaning on and off. Then we can start to understand what we're doing. Here's an example of a PLC program. Steve, tell me about the tallest drop tower in all of Florida.
Well, Falcon's Fury in Tampa is 335 feet tall. And one of the interesting things about timers is they can be used to terrify guests. So when you get on the ride, it takes you up and you're just sitting there looking around, observing. It's great. You can see the skyline, see the horizon, until it tucks you up and you're facing the ground. And the timer I installed kicks on in the program. And it's random from 1 to 15 seconds. So you're going to be staring at the ground for 1 second, wishing it would drop, or you're going to be staring at the ground for 15 seconds, wishing it would drop.
And this can be changed whenever we want. All you have to do is take your laptop, go up to the PLC, change the programming, boom, you're done. There's no changing of the timer. There's nothing physical to change. It's all in the software program. It can be done remotely. Steve and his back at it with all his 300 chickens can be at his home,
It's not quite
typing
300.
away and change something on the PLC program. That's the beauty of PLCs, that you can change things from a distance, and they give you ultimate control. Here's a project that I'm working on right now at the San Francisco airport. This scares most journeymen, especially in my local. We don't do a lot of controls, but I took a call out there because I think we should take this work back. We shouldn't let HVAC fitters be doing our work, which means all of those input-outputs on that controller on the right that you see, that motor starter, the control transformer, all of that is our work. Huh?
That looks no different than a license.